Um, Hello, everybody. This is the session for SIG Cloud Provider, the cloud provider being the part of Kubernetes that is an abstraction layer so that Kubernetes can really be cloud native, hosting things that are portable regardless of what Kubernetes is actually running on. We've got three presenters today. We'll start, I don't know, in the order on the left. So Chris?
Hi, I'm Chris Hoge, and I am a strategic program manager for the OpenStack Foundation, and I'm one of the co-leads of SIG Cloud Provider, and I'm also a co-lead on SIG OpenStack.
I'm Steve Wong. I'm not an official leadership position of SIG Cloud Provider, but I do work in SIG VMware that does the cloud provider for running Kubernetes on top of VMware infrastructure. I work for VMware. I've been active in Kubernetes dating back to 2015, but back in that era, I was mostly active in storage, and I'm also active in the IoT and the Edge working group.
Hi, I'm Walter Fender. I work for Google. I'm one of the TLs on SIG Cloud Provider, and I've been leading the effort to extract the in-tree cloud providers from Kubernetes so that all of the cloud providers can be working on an equal footing.
And Walter's modest, but he also has a lot to do with API machinery, which is the Kubernetes API and also the controller that runs the cloud provider and maybe a few other things. So the agenda today, we're going to get a little bit into, as background, the historical context of how the cloud provider started. And it turns out that the cloud provider started one way, but it's moving in a slightly different direction, and we're going to tell you why it's changing and how it's changing. And finally, we're going to close with a description of how this SIG Cloud Provider SIG actually works, just in case you want to get involved with the activity or learn, even if you're not actively involved, how you can go find the historical record of the agenda, how decisions got made, and maybe look at some YouTube videos, because sometimes that kind of context can help you understand what's going on. So the mission of SIG Cloud Provider is to manage to allow Kubernetes to run in a way that's neutral to all public and private cloud providers. Public cloud providers, you know what those are, but what a private cloud provider means is kind of running on-prem on various forms of infrastructure, whether it be hypervisors, things like OpenStack, and potentially even bare metal. And we're responsible for establishing the standards and requirements that have to be met by all of these providers to have an optimal user experience. So background for these things that this group owns are those KEPs there. I'm not going to summarize them here because they're really detailed, but we'll have a link to this deck at the end. And I think the SCED site has already a PDF of this deck where you can find those links and look at them later. The origin story for cloud providers are, and still the case as of 1.14, that all of these abstraction layers for 8 very popular things to host Kubernetes on are like integrated into the very fabric of Kubernetes itself. Seemed like a good idea when Kubernetes was getting started to make it convenient to where you could just deploy it and it just works. But just like they say in Kubernetes being a host of microservices, monolithic isn't always good. And bundling in these things by default had some issues. What were the issues? Well, really Kubernetes should be an orchestration layer, managing only the standardized parts, not the thorny aspects of that are unique to any particular deployment pattern. People also came to the conclusion that inclusion of these things could constitute an endorsement of a particular platform. The Kubernetes project doesn't want to be a kingmaker coming up with the specific list of what's authorized and not. The other issues are that by bundling in this code, it became very tightly coupled. So suppose, let's take an instance where there's a bug that affects one particular cloud provider. Just in the interest of fairness, I'll hypothetically suggest it's the company I work for. There's a bug in the VMware implementation, security issue, and we need to get it patched right away. Well, if that code is in tree, we have to cut a full Kubernetes release, pass all the tests to get out there, and that slows the release time. You really don't want that to happen. Unless there's a really good reason to tightly couple it like now, there's a lot of value in not having coupled release cycles. It also allows independent releases to these. If one particular cloud provider came out with some fancy feature because they changed something in a particular public cloud, might give them the option to enable that without waiting for a Kubernetes release cycle. So there's both problems and opportunities that can be solved by taking cloud providers out of tree. So I'll turn it over at this point to Chris.
Okay, so with the stage set, we want to understand how can we fix the cloud providers for everybody. And this includes both the providers who are in tree and the providers who are out of tree. To start on that, so there are two major things that we have to do. The first is that you need to make a way to have all of the cloud providers be out of tree. And then once you have accomplished that and set that stage, then you can start taking out the cloud providers out of tree. And then everybody has their own provider. You have experts who are maintaining that code. And it's, and you've kind of achieved that level playing field. So we started by, for all of the supported in-tree providers, the provider code has been officially deprecated and their dependencies are being moved to staging. And Walter has been one of the key people who have been working on this effort, and really driving it forward because he has such a strong expertise in the Kubernetes code base and how to disentangle all of those tightly coupled resources into what we call the Kubernetes staging directory. What would you call that? Yeah, staging subdirectory that where we can say that these are APIs that that providers depend upon and they won't change. With the in-tree providers moved to staging after the upcoming release, they will have a path to removed in the following release. So our goal is that by the end of 2019, there's going to be no in-tree provider code. All of that will be gone. And so if you are running a cloud provider and you have code that's in tree, I think OpenStack is a good example of this because you're more likely to be running your own OpenStack code. You should be thinking about migrating from using what ships with Kubernetes to what ships from the individual provider. And then finally, any unmaintained provider code is going to be removed entirely. And so Kubernetes just had its next release last week, I guess, was when that happened. And then we should be removing that code during this release cycle, right? Yeah, I think the dead code is going to be moving out.
I think you went back.
I went back. Okay. So for the out-of-tree providers, we want to introduce the Cloud Controller Manager. So the Cloud Controller Manager replaces the Kube Controller Manager and is a daemon that embeds the following cloud-specific control loops. The node controller, the route controller, and the service controller. Now, if you're familiar with the Kubernetes code base, you might be thinking, where does my volume controller go? And to kind of help explain that,
I'll take over here because I've been active in SIG storage. So for exactly the same reasons why it made sense to get the cloud provider abstraction layer going down to the actual compute infrastructure out of tree, same rule applied to storage. There were 30 plus storage plugins in Kubernetes. I think it's even more than that if you counted the Flex drivers. And they were tightly coupled and on the same release cycle as Kubernetes. More and more storage solutions were coming to try to jump in the pool, and it just became probably even more unmanageable than it was with cloud providers when it got up to 30 some. any one of which could have bugs holding up a release. And because of this, Kubernetes moved to an architecture called the container storage interface. Now, unlike the cloud provider, the container storage interface is cross container orchestrator. So this is an industry standard that supports not just Kubernetes, but Apache Mesos, Cloud Foundry, Docker, and potentially other orchestrators. So it starts with a vendor doing an implementation of a CSI plugin, and then Kubernetes has a new interface to use the external storage plugin. Now it turns out that this is coupled to the external cloud provider, because I believe it's fair to say that every person maintaining a cloud provider elected that when we transition out of tree on the cloud provider, we don't want to engage in this ugly test matrix of testing external cloud provider with internal storage and again with external storage, and ending up with this grid of things that you have to support. So a decision got made by everybody. I don't know if there ever was an official statement, but practically speaking, if you go to an external cloud provider, you're going to have to go to an external CSI-based storage plugin as well.
Yeah.
And for more on that, we're not going to cover that here because the storage SIG owns that, and they've had sessions that got recorded at past KubeCons as recently as a month ago. So go look at the videos and slide decks for those to learn more.
But it is worth mentioning though that if you are looking for a CSI driver, and there's a good chance that you will find it with the cloud provider code for a particular vendor. So keep that in mind when you're thinking about the storage controllers, that they often wind up in the same place.
Yeah, especially if the CSI driver is specific to the cloud provider. So CSI gets interesting because there are two flavors. There are going to be things like Amazon's EBS CSI driver, and then something like just a local file system driver, which is also CSI. And so those will be found in different places.
And for the ones where you're going to land in an on-prem scenario, typically if you're running on a hypervisor, it will have a bundled CSI, but you're really free to use a bunch of others potentially too that have nothing to do with that hypervisor. So it is entirely possible to use many CSI plugins at the same time, and there are perhaps use cases where it's a smart thing to do.
Right. And it all speaks to the reason why CSI wasn't included directly within the cloud provider.
I'll just put in one more tidbit for migration when you go from in tree to out of tree. Right now on storage, the migration story isn't necessarily fully baked. The plan long term with the storage SIG is to go replace the in-tree storage plugins, which are all still in there, with stub code that will call out to the CSI implementation. But right now, that hasn't been done. So just be advised that that is a consideration if you're engaged in migration. And if you've already got working, previously created persistent volumes, it may or may not be straightforward to do that migration to go from the in-tree to the out-of-tree. It's, I think, fair to say it's potentially plugin dependent, and you should look to the authors of that plugin for advice on how to handle that. Back to you, Chris.
Okay, so we're going to spend a little bit more of this talk discussing the nuts and bolts of how you build your own cloud provider, because this is important if you're providing a cloud service or you want to be involved in the development of someone else's cloud provider. It's important to understand this process. So the first step is you need to write a package that will satisfy the cloud provider interface. The next step is to create a copy of the Cloud Controller Manager main.go and import your package. And so you're taking the package that implements the interface and you're wrapping it inside of an executable that is common amongst all the cloud providers and initializes, it has an init block that loads your provider code. And then finally, you go through the work of publishing, which means building, testing, building it, testing that your code works, both through integration testing as well as functional testing, packaging it inside of a container so that you can launch it as an application, and maintaining it and supporting your customers who are going to be consuming this cloud provider. So at a high level, to build the out-of-tree provider, you need to implement the cloud provider interface. And there are several interfaces that you have to implement, and you may not actually implement all of them. If your cloud doesn't provide one of these, then every one of these has an optional flag to say that you don't support that, and the cloud controller manager will ignore it. And so this includes the load balancer interface, so cloud-specific ingress controllers is covered by this. Instances, which is cloud-specific information about nodes within your cluster. Zones, which are cloud-specific information about the host availability zones. And so if you have a cloud that spans multiple zones, this gives you a way to handle clusters that are spread across those zones. As well as cluster-specific clusters, which is cloud-specific information about the running clusters. So if you have multiple clusters running. And finally, routes. And so cloud-specific information about networking. So this is the actual code. This is the actual provider that you have to implement. And so there's an initializer, and then a method that returns that returns if each of these are set, and an object that is an implementation of that particular interface. Okay, so once you've implemented that provider, then you need to build your cloud controller binary. So the external cloud controller runs as a separate binary that interacts with the Kubernetes API service. It's configured with a standard set of options, and these can be extended to match the requirements of your cloud. And a starting template is provided by the Kubernetes Cloud Controller Manager directory. We have a link to that right there. And on the next slide, we also have just, again, I've cut a little bit of the code out because there are a lot of comments there. But this is basically the gist of everything that you need to be able to create your binary. So you bring in a number of imports, including your cloud provider, as well as some optional, the Prometheus client Go plugins and for metric registration. And you basically have an initializer log. So you set your cloud controller manager command, initialize the logs, and then execute the command. And all of your command line options are kind of pulled in and set up beforehand in the Cloud Controller Manager app. So it's a great way to get started. You will likely want to have your own configurations on there. You may want to pull some of the configurations out to simplify for your users. Okay, once it's built, you want to have two types of tests at minimum. The first is unit tests, all the appropriate mocks to guarantee your implementation behaves as expected functionally. But also importantly, when you load the Cloud Controller Manager, the Kubernetes behavior is going to change to use all of the implementations that you have provided. And so you want to make sure that Kubernetes is behaving exactly the way it's expected to behave. And you accomplish this by running the standard end-to-end tests with the provider enabled on the instance of your cloud for full integration and conformance testing. And then once you've done this, you want to enable release gating against your cloud. And so this has to be implemented. So both have to be implemented, and you need to run the end-to-end testings, and these have to be reported to test grid. If you've done this and you can demonstrate that your particular cloud has implemented these tests and also has a critical mass of users, then your cloud can become these tests will become gating for the Kubernetes release.
And we'll give you Kubernetes certified status.
Yeah, right, which is
and the key is, even though they're moved out of tree, so they're not part of Kubernetes, it's possible that somebody made a change to Kubernetes itself that broke it when running on your cloud, even if your cloud provider is fully compliant and passes all your tests, and we want to know about that.
Okay, so finally, once you've built your cloud provider, then you want to run it. And so to accomplish this, there are a few things that you have to do. When you start your Kube API server, where previously you would say cloud provider and the name of your cloud provider, instead you specify cloud provider external. Then when you start your CCM binary, you set the cloud provider flag to be the name of your cloud provider, and then the cloud config flag to the path of your cloud configuration. Now the similarity in options comes from the scaffolding code. The cost of this is that there are a lot of unneeded options that are being pulled over to the cloud provider, and this is there's actually an issue that is actually pretty old by now, but it's still something that I think longer term the SIG Cloud Provider should be looking at addressing.
And one quick note, the cloud provider external is actually a flag that not only the Kube API server, but the KCM, the Kube Controller Manager, and the kubelet also need that flag set.
Yeah, yeah. They all need to be aware that the cloud integrations are being handled by an external provider in an external binary. Okay, so when you're running in production, use a daemon set. This is why they were made. And your cluster behavior will change in a few ways. Notably, specifying cloud provider external will add a taint to node.cloudprovider.kubernetes.io uninitialized. The effect of this will be that there will be a no schedule during initialization. And so the assumption is that you actually can't do work on the cloud until your cloud provider is up. So you set the taint to make sure that you give the cloud provider time to initialize. Cloud information about the nodes in the cluster will no longer be retrieved using local metadata, but instead all API calls to retrieve node information will go through a cloud controller manager. This means that for larger clusters, you may want to consider if your cloud controller manager will hit rate limits, because there's going to be a lot of communication between the Kubernetes API and your cloud API. And it's going to be responsible for almost all the API clouds you make to your cloud from within the cluster. And so this is something that you'll want to think about because there have been reports of cloud providers who Kubernetes hits the rate limiting on the cloud, and you'll want to adjust those limits appropriately if you know that you're going to be running Kubernetes inside of your cloud with that integration in place. And so it's important to note, that once you that you set a toleration also so that the CCM can bootstrap itself. So that once you load the cloud provider, you want to be able to load that, if you're running it as a daemon set, that you load it, that you ignore the taint so that it can be scheduled and it can be brought up and that process can be started. And so this is also another important aspect of when you decide to run it as a daemon set. This is how you make it so that the cloud controller can be scheduled and started so that the entire Kubernetes cloud can initialize. Okay, finally, there are some implementation details that you want to consider. What library are you going to use to interact with your cloud? Typically, you're going to have some sort of library which is, probably in Go that interacts with your cloud. How are you going to handle authentication and authorization? And this is actually a problem that goes much further because you may have a number of different integrations with your cloud, particularly with the new cluster API. And you'll want to make sure that you abstract how you handle authentication and authorization, which means that you'll want to build an external library to handle that. And these are the things you want to think about when you're building your provider, of all of the pieces that'll possibly be used by other components that will be shared. Okay.
Go ahead one more slide. We said thank you because this is the end of the organized presentation, but I think there's a link for Q&A and how to get involved and how to find this deck. So maybe one more. We'll do Q&A, but I'll leave this up because there's the link to the deck.
Yep. So if you want to join the Cloud Provider SIG, we have a Slack channel, SIG Cloud Provider. And all of the cloud providers themselves also have their own Slack channels, so you can communicate with them. The Google group is a Kubernetes SIG Cloud Provider. It's a fairly low volume mailing list, but important communication does happen on that.
And you should join the group because a lot of the documents have access gated to members only.
Mm-hmm.
So there's no particular qualifications other than providing an email. But once you join the group, it will end these situations where you'll see a doc list link, try to open it, and you'll get permission denied. So
the other thing is if you have problems in Slack or Google, you can always open an issue on SIG Cloud Provider and begin a chat that way.
Yeah. And I'm one of the chairs of the SIG, along with Jago McLeod and Andrew Sai Kim. But really, one of the great things about SIG Cloud Provider is there's a tremendous amount of work that's going on, and even though there are like the SIG chairs, when you show up and you do work within the SIG, it's actually you are seen as a leader within the SIG, and and there's a tremendous amount of work that can be done, particularly in finalizing the extraction process, and then coming up with these commonalities that we're going to be sharing across the providers. And so if this is work that you're interested in, please show up in the Slack channel, show up in GitHub, talk about the issues that you want to work on, and we are more than happy to guide you in the direction to become, positive contributors to the SIG.
okay, with that, does anyone have any questions? Sure. Can you let them borrow your mic?
Of course.
Oh, we've got another one coming.
Well, my data center based on the old world, the program of virtualization program. We built the data center based on the old world. I know that there's a cloud provider to provide. If I want to build the Kubernetes cluster based on the old world cluster, and we can use the use SIG team plugins to help us to build the Kubernetes based on the overt cluster. I want to know the details how you program to scheduling the container based on the overt.
I'm not familiar with Overt. I do represent, a hypervisor-based cloud provider, and I think Chris does as well.
Is Overt one of the cloud providers that we haven't found developers for? Yeah, so Overt is one of the entry providers that is going to be removed. So if you are interested in continuing Overt development, then you'll want to actually use some of the things we talked about here to build an external provider for that. But essentially, so I think if I understand your question, it's how do you schedule the nodes on the cluster? And SIG Cloud Provider doesn't worry about how a node is created. The assumption is that there is some mechanism that has created the nodes inside of your cloud, and that you've started up the processes inside of that node that are going to be part. So you've either designated a node as a control node, or you've designated it as a working node, and then the cloud provider becomes aware of those and communicates.
So if I can add to that, the first thing I'd mention is I would go talk to SIG cluster lifecycle, because how do nodes come into an existence is something that's usually dealt with by cluster lifecycle.
Right.
Now, once the node exists and it has been created in Kubernetes, how you provision that node according to the cloud provider, that is exactly what the cloud provider, SIG Cloud Provider, is concerned about. But getting the node into existence, you need to talk to cluster lifecycle.
Yeah.
And then beyond that, if you did want to influence placement of workloads with scheduling, then the zones come into play. If you choose to,
right? Well, that's because zones are a little bit higher level. There's actually there's the node interface, which understands, is able to tell, what sort of node you have, what its memory and CPU capacity is, what sort of workload is on it right now, and and that will be the thing that it will read data from the cloud API to help determine how it schedules workloads to the different nodes.
I need write a driver, like a driver, to help the.
Yeah, for future releases of Kubernetes, we're going to need someone, and maybe that would be you, would write an external cloud provider for Overt.
Oh, thank you.
And to be more specific, if you want to not go through too much pain, well, maybe you may want to think about helping us actually move Overt into staging rather than having us just delete it if it's something you care about. Because once it's deleted, you're going to have to go in the look back machine to find an older version of it and probably copy that. And if you can just keep it going, you may be better off.
Right, and moving it into staging will extend the life cycle of that internal provider for at least one more release.
Before you have to then get it, find a home for it. And definitely come to SIG Cloud Provider, because finding homes for things like that is one of the things that we do.
Right. In our meetings, we should probably have our meeting times up here. They're Thursdays at.
Well, you see,
Wednesday.
you can only tell them one time zone too, and
or I usually
over.
usually say UTC. So, but
anyway, if you join the group, you'll see the calendar and learn when the meetings are. They might not be at times friendly for China, but.
Right, and if you are interested, if we have enough people who are interested in a different time that is more accommodating towards the Asia Pacific time zone, as a community, we are always welcome, to the idea of if there is demand for for people to be able to attend the meetings at a time that's good for them, to accommodate that either by changing the meeting time or adding a TikTok meeting so that it's U.S. European friendly one time and Asia Pacific friendly on the other time.
I think we have time for at most one more question, because there's people stacking up to use the room for the next one. Anybody got a last one? Otherwise, we can hang out in the hall.
Hi.
Hi.
I'm Oxen from the Alibaba Cloud, and I want to know the future roadmap for CCM.
So CCM, or for cloud provider extraction, or for cloud provider? So I think the big thing we're working on right now is trying to get everyone to doing a standardized build out of tree, test grid integration, and moving Kubernetes to a kernel model. And I think that particular schedule is currently taking us through the end of 2020. If you look up Andrew Sykim, and you look for the roadmap, he actually has a very nice breakdown quarter by quarter of what each of our goals are for cloud provider extraction and cloud provider through the end of 2020. Once we have everyone out, I think there's going to be a lot of, looking in and trying to determine what's next. I imagine that's a lot of how do we make a better interface to doing various things that are undoubtedly going to be coming up. It may be things like how to support specialized custom hardware. Do we want to move to more of the CSI style model for some of the various pieces? Also, we have this never-ending list of these little tweaky things about things like how do nodes get named. How can we make that consistent across cloud providers for transitions, for hybrid clouds, for that sort of thing? And also for things like, how do you determine a node is dead? And what are the calls that need to be made? Nodes have health checks that they make against the Kube API server. When a certain number has been missed, now we have to determine, okay, is this node just slightly unhealthy, or was it removed by the underlying cloud? And so some of those sort of life cycle models need to be looked at fairly closely.
Okay, thanks. I think we're going to have to cut off questions, but I, for one, am willing to hang out in the hall if anybody got cut off.